Okay. All right, so this is a representation of a dollar. Does everybody agree that a dollar is equal to 4 quarters? This is a representation of a dollar. A dollar equals 10 dimes. Does everybody agree? So if this picture equals a dollar and this picture equals a dollar, couldn't you say that this picture is equivalent to this picture? Everybody agree? Okay. So if I tell you that this f of x, or this function, is equal to the absolute value of x, and if I tell you that this function is equal to 5, would you agree that they're equal to each other? I'm going to let you think about that for a second. You guys agreed that those were equal. Doesn't this say that it's equal? And this says that this is equal? This particular function is equal to this. This one. Don't they match? Well, this particular one, f of x, right? It's the same f of x. They're the same. In this case, if I'm talking about f of x and I graph it, the only time it's going to be different is if I start talking about g of x or h of x. But whatever is on this screen, when I'm talking about a function, if it's f of x, then it is the same as that f of x. So they are actually equal. Okay? You agree? All right. I think on this screen is where I want to say, for instance, I'm going to substitute 5 in for x. No, I'm not going to do that here. All right, let's keep going. All right, so here's where we look at it graphically. So this is the function f of x equals the absolute value of x. It's right here, what we did yesterday. It does not have a horizontal shift, and it does not have a vertical shift. It has a slope of 1, because there's nothing there, so it's just up 1, over 1, up 1, over 1, up 1, over 1. That's the parent graph. Very good, Philip. Yeah, he is. Okay. Yes, you may have your phone. Okay, so f of x equals 5. So we learned how to graph those in the very beginning of this unit by going up 1, 2, 3, 4, 5, and just drawing a straight line. It's constantly 5, always 5. Okay. So for what values of f of x is for what values of x is f of x equal to 5? So how are we going to solve this? Check this out. Does anybody know the answer to this? I'm curious. Do you guys remember how to do this back in Algebra 1? Okay, wait. Let's hear it. No, Philip's been talking a lot. Sarah? Wait. You set them both equal to 0. But you know there's 2 things you have to do, right? Remember this? X equals -5 and x equals 5. Remember that? Oh. Listen. Guys, listen up. And this is why. If I substitute in 5 into this equation, it's still, let's put it over here. If I substitute 5 in there, it still is 5. And if I substitute -5 in there, it's still 5. So that's why the absolute value of x equals 5. Now, check this out. Ready to be blown away? Yeah, Tristan says. Okay. check this out. The intersection, remember when we first started the unit and the intersection was the solution to the problem? We talked about what? Sports teams and getting season tickets and the jersey thing, remember? And where they cross, what do we call that? The intersection. And where they intersect is where they're both the same, right? So check this out. Their intersections are when x equals 5 and when x equals -5. So I just solved this absolute value equation graphically. Well, it's going to change. It's not always going to be this easy, right? I'm going to kind of go through these quickly. So let's see. If I keep my parent graph and I change it, what if f of x equals 8, 5, 6, 7, 8? What do you think those solutions are going to be? 8 and -8. And this one. What if it's 0? X equals 0. And what if it's -2? What happens then? It's not 0. Check this out. Oh, I heard it. What was it? No solution. Check this out. If the absolute value of x is -2, do you guys remember from Algebra 1? The absolute value can never be negative, right? Because the distance is never measured in negative, right? Distance is always positive. So if it's the distance away from 0 on a number line, it has to be positive. So that's why this one is no solution. But if that doesn't make sense to you, you should see that there's no time that the parent graph is interacting with that line. That's why there's no solution. There's a visual representation of that. Because it just doesn't touch. So let me play with this a little bit with you. Okay. This is what we're doing today. To be able to solve absolute equations graphically. All right, here is a story problem. Story. Okay, it says the bottom of a river makes a V shape that can be modeled with an absolute value function. D of h equals 1/5. I'm going to change this really quick. Equals 1/5 times the absolute value of h minus 240 minus 48. So this is d of h. We're going to add 48 to both sides. Equals 1/5 times absolute value of h minus 240. What does this mean? Well, let's finish a little bit of the problem. Where D is the depth of the river bottom in feet, and h is the horizontal distance to the left-hand shore. Okay, so if I were to graph this, it would look like this, where if I want to find my depth, I would look at the horizontal stretch out here. So let's keep reading the problem. It says, a ship risks running aground at the bottom of its keel. The keel is its lowest point under the water, reaches down to the river bottom. Suppose you are the harbor master and you want to place buoys where the river bottom is 30 feet below the surface. How far from the left-hand shore should you place the buoys? This is actually a pretty cool problem. So it says that, we'll put this one. It says that d of h equals -30, right? That's what it said. So at -30, we would be, let's see, if this is -40, then -30, this is -20. -30 is probably about right here. That's a little too low. But it's okay for these purposes. So the intersection is going to be somewhere between x equals 160 and x equals 320. About, I'm going to say about. Now that's super important, right? Because what that's saying is that if a ship goes alongside a shoreline and there's a part of the ocean floor that is not as deep as the rest, then if you put two buoys, the ship knows that it's supposed to go in between those two buoys so that it won't hit the bottom of the ocean. Have you guys ever seen that? Like on a river or a lake where you have to drive through two buoys? The little floaty things on the top of the water? That's what those are, to warn you that there's something there that you need to watch out for. Nope. In Lake Tahoe, to get into Emerald Bay, it's a very narrow spot, and the buoys last year were further out, that the lake water is now really low, and so they had to move the buoys in to make sure boats know where to go. Okay. All right, so the reason now we can do graphically. Graphically is kind of cool, but if I want to know and tell a ship where it needs to go, I better be pretty accurate. So graphing isn't really accurate in this problem, right? So what we need to do is tomorrow we're going to do it algebraically. We'll do this problem algebraically. All right, moving on. Pencils down. So I'm going to graph these two functions, x minus 2 plus 4. So I'm going to change it over to transformational form. So f of x, I need to move my constant to the other side. So instead of being positive 4, it's going to be negative 4. Absolute value of x minus 2. I know from yesterday that this means I need to make a horizontal shift of where x equals 2. And this one is a vertical shift where y is equal to 4. So I know that that's my vertex right there. My vertex is 2, 4. So I'm going to go over 2, horizontal shift of 2, and positive 4. 1, 2, 3, 4. My slope, there is no slope right here, so it must be a 1. So I'm going to go up 1, over 1. Up 1, over 1. In both directions. And in my last class, I decided I was going to be lazy and not draw all of these dots, and I messed up. And then I tried to check it, and then I was wrong. And I was like, why am I wrong? Oh, because I was being lazy. All right. Secondly, now I have g of x equals 7. So I know that's just a constant line. 1, 2, 3, 4, 5, 6, 7. Oops. 2, 3, 4, 5, 6, 7. Graph that one. So now I have intersection. So my intersections are at 1, 2, 3, 4, 5, x equals 5, and my other intersection is at x equals negative 1. So this is kind of, I'm showing you the reverse. This is what the problem would have looked like originally. So I took the x minus 2 plus 4 and I changed it into its own function, and then I took the 7 on the other side and I changed it to its own function. And when I make sure that I locate my intersection, I found two solutions to this problem right here. Okay, I'm going to do one more clean one, but it looks just like your homework. Okay? So pencils down. First thing I'm going to do is I'm going to ask myself, what two functions am I graphing? My first function is negative 1/3, absolute value of x plus 2. Whoops, wrong one. My second function that I'm going to graph is g of x, when g of x equals negative 1. Let me put this one in transformational form. So I'm going to take that 2 and move it to the other side. So I would have f of x minus 2 equals negative 1/3 times the absolute value of x. I'm going to ask myself, what is my horizontal shift? Nothing. And what is my vertical shift? My vertical shift is 2. So I'm going to graph this. I'm going to go over 0 and up 2. Over 0 and up 2. My slope is negative 1/3, so I'm going to go down 1 over 1, 2, 3. Down 1 over 1, 2, 3. Down 1 over 1, 2, 3. Same thing on the other side. Down 1 over 1, 2, 3. Down 1 over 1, 2, 3. Down 1 over 1, 2, 3. Tired of talking. You guys need to get working. Graph both my intersections. Sorry, graph both my functions. There we go. -1. This is -1. What, Philip? I still hear whispering. So here x is 9, and here x is -9. So the answer, the solution to this problem right here is -9 and 9. Can you guys show me one? Questions? Yes, Philip. Why is it just the absolute value of x? Because there is no shift on the x-axis. Okay, we're going to change it because it's confusing you. Well, if it's confusing you, it could be confusing somebody else. So this is x minus 0 plus 2. Better? And this is x minus 0. I don't know why I didn't do that in the first place. Because I just look at it and realize it's 0. Better? Okay, fantastic. All right, thumbs up, thumbs down. You guys want to try one on your own? Well, if you want to try on your own, give me a thumbs up. If you'd like me to do another one, then thumbs down. Okay, I got enough thumbs down. Okay. Let's do one more. Okay. So, I've got 2 different equations here. Or 2 different functions. I'm going to split it into 2 different functions. First one. How do I what? Okay. So I've got my first function is going to be the absolute value of x minus 3 plus 2. And my second function is going to be g of x equals 5. This one's already done. I've got to transform this one. So I'm going to take that 2 and move it to the other side. So f of x minus 2 equals x minus 3. My horizontal shift is positive 3. My vertical shift is y equals 2. Then I'm going to go over here and I'm going to say I got to go over 1, 2, 3, and I have to go up 1, 2. My slope, there is no slope there, so that means there's an invisible 1. Probably shouldn't use that color. There's an invisible 1 there. So it's just up 1, over 1, up 1, over 1, up 1, over 1. I should get rid of these dots. There's no tutoring right now, but you guys have my YouTube videos. Is anybody watching them? Graph my g of x, which is at positive 5. 1, 2, 3, 4, 5. I did it again, Miss Wiz. I did the easier one. Yeah, taking it. This was the easier problem. I should have done the harder one that's on the next slide. Okay. So my solutions are at when x is 1, 2, 3, 4, 5, 6, x equals 6, and my other solution is when x equals 0. Question? So, yes, Francia? No? Okay, so, Philip. Are there always two answers? You guys tell me.
Yes, there should be no answer.
Okay. This is a good question. So right now there's 2. Could there ever be 3? There's this side and there's this side. Is there anything else to touch? It would have to cross another blue line to have a third solution, right? So you can't have more than 2. How many solutions are there? 3. How many solutions are there now? None. Yeah, when it's crossing, there's always 2. Yes. There can never be more than 2. Okay, let's see which one I want to do with you guys. Yes. The parent graph won't be switched to that side because that's not a function because it doesn't pass the line test. But it will be pointing, it could be pointing down. Okay, I'm going to start this one off for you guys, okay? So I'm going to change it a little bit. So I'm going to say the function, we've got our blue one on this side, and then our red one. Too much talking, guys. Don't make me go over and pick up that blue pen. Okay, so my function of x is equal to, I'm going to take that -3 out of the absolute value equation, right? Because it really means this. Stay there. You need this for your homework, and I got to give you your homework. Okay, does everybody see that? If I were to redistribute it in here, it would be the same thing, right? Now, the absolute value of -3 is only +3. And you guys could do it from here. So let me pass out your homework and you can go.